Hello, welcome. I am by name Samuel Babatunde, and we'll be continuing further on our mathematics class. Remember, previously we discussed about Roman numeral, that's the Roman system of numbering, and I showed you how the Roman numeral system works. That is, how the Romans use letters, capital letters, to represent numbers. And then we did some solvings. I gave you an assignment, and then we discussed and we looked how to do all this in what Roman numerals, how to numbers, and what each of these letters represent. So today we're going to be moving further. We'll be looking at what we call factors. That's factors of numbers. So we're going to be looking at factors of numbers today on mathematics. So, factors. I believe we've come across this even in our schools and while reading factors. So I say, if a whole number divides into another number n, if a whole number divides, like you can see now on my screen, if a whole number divides into another number n without remainder, the number is a factor of n. Now, what do I mean by this statement? Let's take, for instance, now I have a number which is 6. Let's say my number now, n, is 6, right? And then I have a whole number, 2. And this 2 now can divide into this 6 without any remainder. Like we know, 2 can go into 6 3 times without any what remainder. Now I say what? This 3 is a factor of 6. This 3 is a factor of 6. I already have an example here. So I'm going to be doing this example. I say 40 divided by 8 is equal to 5. And 40 divided by 5 is equal to 8. Now, what do I mean? It means that what? 8 and 5 are factors of 40. I believe you understand what I mean now. So, 8 and 5 are factors of 40. Why? Because 8 can divide into 5, into 40, without any remainder. So, 8 will go into 40 5 times without any remainder. Likewise, 5. 5 can go into 40 8 times without any remainder. So that's why I say what? 5 and 8 are factors of 40. Now, mind you, 5 and 8 are not the only factors of 40. I'm just giving you an example to understand what I mean. To understand the statement that I said, if a whole number divides into another number, n, without remainder, the number is a factor of n. So therefore, if 8, a whole number, divides into another number n, which is 40, without any remainder, definitely when 8 going into 40, it will go what? 5 times without any remainder. Therefore, 8 is a factor of what? 40. And 5, which is a whole number, when it can divide into 40 without any remainder, it means that what? 5 is a factor of 40. I believe that is clear. We say that 8 and 5 are factors of 40 because they can divide into 40 without any remainder. The number 1, 2, 4, 5, 8, 10, 20, and 40 all divide into what? 40. They are all factors of 40. Yes, 1 can go into 40 without remainder. It will go into 40 40 times. 2 can go into 40 20 times. 4 can go into 40 10 times. 5 can go into 40 80 times. 8 can go into 40 5 times. 10 can go into 40 4 times. 20 can go into 40 2 times. And 40 can go into 40 what? 1 time without a remainder. So therefore, 1, 2, 4, 5, 8, 10, 20, and 40 are what? Factors of 40. They are all factors of 40. So that's what simple meaning, that what factors actually what mean. When a number can divide into another number without remainder, the number is a factor of what? That number. So because 5 can go into 40 8 times without any remainder, 5 is a factor of 40. Because 8 can go into 40 5 times without any remainder, 8 is a factor of what? Is a factor of 40. I believe that is clear. Now, I have an example here. I say write 40 as a product of two factors of 8 ways. Now, this question already will tell you that what there are 8 ways by which what you can write 40 as a product of 2 factors. Remember, I said factor is a number that can divide into another number n without any remainder. So, and now I said write 40 as a product of 2 factors of 8 ways. That is now express 40 as a product of 2 factors in 8 ways. In 8 ways. Now, the first here you have that 1 times 40 will give you what? 40. That's a way. And remember, 1 is a factor of what? Look at it. 1 is a factor of 40. And what? 40 is a factor of 40 because 1 can go into 40 times without any remainder, and 40 can go into 40 one time without a remainder. So 1 and 40 is a factor of 40. Likewise, 2 times 20 will give you what? 40, meaning 2 can go into 40 20 times without any remainder, and 20 can go into what? 40 2 times without any remainder, meaning that what? 2 and 20 are what? Factors of 40. And so therefore, 40 can be expressed as a product of what? 2 and 20. So 2 times 20 will give us 40. Likewise, I said 4 times 10. 4 times 10 will give us what? 40, meaning that what? 4 can go into 40 10 times without any remainder, and 10 can go into 40 4 times without any remainder, meaning 4 and 10 are factors of what? 40. So 40 is expressed what? As a product of 4 times 10, which are the factors of 40. Also, 5 times 8. 5 can go into 40 8 times without a remainder, and 8 can go into 40 5 times without any remainder. So therefore, 5 and 8 are factors of 40, and thereby 40 is expressed as a product of these 2 factors, which are its own factors. 5 times 8 to give you what? 40. Also, you have 8 times 5. Now, this is like just a reverse. 8 can go into 40 what? 5 times without a remainder, and 5 can go into 40 8 times without any remainder. 8 times 5 will give you 40, meaning that you can express 40 as a product of these 2 factors, 8 and 5. Likewise, 10 can go into 40 4 times, and 4 can go into 40 10 times. So therefore, 10 times 4 will give you 40, meaning you can express 40 as a product of these 2 factors, 10 and 4. We also have 20 times 2. 20 can go into 40 2 times, and 2 can go into 40 20 times. So therefore, 20 times 2 will give you 40, meaning 40 can be expressed as a product of these 2 factors, 20 and 40. And lastly, we have 40 times 1. 40 in 40 will give us 1 without a remainder, and 1 in 40 will give us what? 40 without any remainder. So therefore, 40 can be expressed as a product of what? 40 and 1, because these two what are factors of 40. So you see, when you count it, you have 1 2 3 4 5 6 7 8. So now 40 has been expressed as a product of the 2 factors in 8 ways. We've expressed 40 what as a product of 2 factors in 8 ways. Okay, so now move on to what? Prime number. I believe you understand what factor is now. I believe you understand what factor is. I said what factor, if a whole number divides into another number n without a remainder, meaning if 8 divides into 40 without any remainder, 8 is a product and factor of what? 40. So now we're moving to what? Prime numbers. Now, what are prime numbers? Say a prime number has only 2 factors. A prime number has only 2 factors, meaning a prime number has only 2 numbers that can divide into it and has what? No remainder. So a prime number only have what? 2 factors. That's it has only 2 numbers that can divide into it without any remainder. And these 2 factors are what? 1 and itself. So these are prime numbers. A prime number has only 2 factors, itself and 1. Itself and 1, meaning that it is only 1 and itself that can divide this number. For instance, 2, for example, is a what? Is a prime number. Now 2 can only be divided by 1 and itself 2, meaning that what? 2 is a prime number because it has only 2 factors, which are itself and 1. Another example is 3. 3 is a prime number because 3 can only be divided by what? 1 and itself 3. Meaning that what? 3 is a prime number. It has only 2 factors. So prime number are numbers that has only what? 2 factors. They have only 2 factors. Another example is 5. 5 can only be divided by 1 and itself, making it a what? A prime number. 7 same. 7 can only be divided by 1 and itself. 7 cannot be divided by 2. No. There will be a remainder. It cannot be divided by 3. No. It cannot be divided by 4. No. It cannot be divided by 5. No. It can only be divided by what? 1 and itself, meaning 7 has only 2 factors, thereby making it what? A prime number. 11 also same, can only be divided by 1 and itself. Likewise 13 and so on. So all these are prime numbers because what? They have only 2 factors, itself and 1. Itself and 1. Now mind you, 1 is not a prime number. 1 is not a prime number. Why? Because from the law or from the definition, a prime number has only 2 factors, itself and 1. But now when you look at 1 has only what? 1 factor, itself. It has just 1 factor. So it cannot be what? A prime number, and it's not and will never be a prime number. So 1 is not a prime number because what? It has only 1 factor. And the definition says prime number has only 2 factors, itself and 1, but 1 has only 1 factor, which is itself. So 1 is not a prime number. I believe that is clear. Now, prime factors. Prime factors. We'll talk about factors, we'll talk about prime numbers. Now we're going to be combining these two together, the factors and the prime numbers, to give us what? Prime factors. Remember, we say factors what? Factors are number that can what? Divide into another number n without a remainder. So we say, well, this number are factors of n. Then we say prime numbers are numbers that can only be divided by itself and 1, meaning they have only 2 factors. Now combining these two, we have what? Prime factors. Now what are prime factors? We see the prime factors of a number are the factors of the number that are prime numbers. The factors of a number, the prime factors of a number are the factors of the number that are prime numbers. Now what do I mean? If I have 15, 15 is my number now, and I have 15 as my number. Now, what are the factors of this 15 that are prime number? If you get that English, what are the factors of this 15 that are prime number? Of course, we have factors for 15. 3, 5. So 3 times 5 will give us what? 15. 1 times, we have 1, we have 3, we have 5, we have 15 itself. These are what? Factors of 15. But then out of all these factors, which is a prime number? Which of these factors are prime numbers? So that's what you call what? Prime factors. They are the factors of a number that are prime numbers. Now, out of all these factors, 3 and 5 are prime numbers because what? They can only be divided by themselves and 1. So they are prime numbers, and automatically they are the what? Prime factors of 15. I picked 24. Factors of 24 include 1, you have 2, you have 3, you have 4, you have 6, you have 8, you have 12, and then you have 24 itself. Now, out of all these that I just mentioned, which of these factors are prime numbers? For us to get the prime factor of this 24, we have to understand that we have to look for the prime numbers in all these factors. And now the prime numbers in the factors of 24 are 2 and 3. 2 and 3, because what? It's only 2 and 3 that is divisible by itself and 1. 4 is a factor of 24, but not a prime factor, because what? 4 is divided by 1, can divided by 2, and can divided by itself 4. So it has 3 factors. Automatically, 4 is not a prime number. 6 can divided by 1, 2, 3, and 6 itself. So it's not a prime factor, but it's still a factor of 24. So prime factors of a number are the factors of the number that are prime numbers. factors of the numbers that are prime numbers. Say it is possible to write every non-prime numbers as a product of prime factors. For example, I have 15 and I want to express 15 as a product of what its prime factors. I want to express 15 as a product of its prime factors. Now, out of all the factors of 15, which are 1, 3, 5, and 15 itself, which of these are prime numbers? 3 and 5. So therefore, for me to express 15 as a product of its prime numbers, what do I do? Its prime factors, I just pick out my 3 and what? And 5. And I say what? 3 times 5 will give me 15. So now I have expressed 15 as a product of its what? Prime factors. Likewise, I have 24. The product of 24 include 1, 2, 3, 6, 4, 6, 8, 12, and 24. But now I want to what? I want to represent what? 24 in the product of what? Of its prime factors. Now the prime numbers in its factors, which are just 2 and 3, because it's only 2 and 3 that are prime factors of 24. I want to express 24 as a product of these prime factors. Now what do I do? Definitely 2 times 2 will give me what? Will give me 4. 4 times 2 will give me what? Will give me 8. And 8 times 3 will give me 24. So I have successfully what? Represented 24 as a product of its prime factors. And if I continue, let me take you to this. This will help us understand. I said to find the prime factors of a number. To find the prime factors of a number, start with the lowest prime number, 2. To find the prime factors of a number, for me to be able to get the prime factors of a number, like we have here now, we have what? 24. For me to get the prime factors of what? Of 24, what do? I start with the what? With the lowest prime number, 2. Yes, 2 is the lowest prime number. 1 is not a prime number. We've seen that already, that 1 can only be divided by itself. So it's not a prime number, because a prime number are numbers that can be divided by themselves and 1. So we start with the lowest prime number. To find the prime factors of a number, we start with the lowest prime number, which is 2. Now you find out if this number now is divisible by what? By 2. If it will not divide by 2, if it's not divisible by 2, what do? You now try the next prime number, which is 3. Take for instance now 24. You find out, okay, 24 divided by 2. Can 24 go and can 2 go into 24? Yes, you now continue with 2. But if it's something like 15, you know that 2 cannot go into 15. 15 is not divisible by 2. What do? You just skip 2 and move to the next prime number, which is 3. And you check again. Is 15 divisible by 3? Yes. Then you start with what? You start with 3. But if in a case 15 is the number is not divisible by 3, what do? You skip 3 and move to the what? Next prime number, which is 5. So like that in turn. So to find a prime factor of a number, you start with the lowest, which is 2. Find out if this will divide into the number. If it will not, you go to the next prime number, which is 3. Now the second point says if a prime number will divide, check again if it can divide it before moving to the what? Next prime number. Now let me show you what this statement means. Now we have what? 24 here. Our lowest prime number, for the first point says, start with the lowest prime number is 2. Now, I start with 2. Definitely, 2 is a prime number, and to go into 24. So 24 is divisible by 2. I don't need to jump to 3 now, because 24 is divisible by 2. Now, if 24 divide 2, what will be left? I'll have 12 left. Now, check if these 2, that's what the second point is saying. The second point says that if a prime number will divide, check if it will divide again before moving on to the next prime number. Meaning, since 2 has gone into the 24 already, and I have 12 remaining, and I have 12, because 2 in 24 is 12. Check again if this 2 can go into the 12. If it can go, then you use the 2 again before moving forward. But if it can't, you now move forward to the what? To the next prime number, which is 3. But now, because 2 can go into 12 to give me 6, I pick what? I still pick what? 2. Now I'll check again. Can 2 go into 6? Yes, 2 can go into 6. I pick the what? The next 2. I won't pick 3 because 2 can still go into 6. So you have to start with the what? With the lowest prime number first. The lowest, that's the law. You start with the lowest prime number first before moving to the what? To the next prime number. So I started with 2. 2 can go into 24. I have 12. 2 can still go into 12. I have 6. Now, 2 can still go into 6. Now it's remaining 3. Now you check again. Can 2 go into this 3? No, 2 cannot go into 3 because what? 1 will remain. So what do? I move now to the next what? Prime number, which is 3. And now I say what? Can 3 go into 3? Yes, 3 will go into 3 once without a remainder. So I write down 3. Now when you look at this and you calculate it together, 2 times 2 will give us what? 4. 4 times 2 will give us 8. And 8 times 3 will give us 24. So what? We've expressed 24 as a product of its what? Prime factors. Now, let's check out 42. 42 says, now we're going to express 42 as a product of its prime factors now. Now, using this law, which I gave, I say to find the prime factors of a number, you start with the what? Lowest prime number 2. So I'm going to be starting with my lowest prime number, which is 2. Now 2, we go into what? 42, 21 times without a remainder. 21 times without a remainder. So I have my 2. Now you check again. Since 42 is divisible by 2, can 2 go into the 21? Because 2 will go into 42 21 times. I check, can 2 go into 21? No, 2 cannot go into what? 21. So what? I move to the what? Next prime number, which is 3. So 3 will go into 21 7 times. So I put down my 3 because 3 can go into what? 21. Now I check again, can 3 go into 7? Because 3 can go into 21 7 times. So this 7 now, can 3 go into 8? No. What do? I move to my next prime number, which is 5. Now I check again. Can 5 go into 7? No. 5 cannot go into 7. I move again to my next what? Prime number, which is 7. Now can 7 go into 7? Yes. 7 can go into 7 once. So therefore, I put down my what? 7. And I calculate 2 times 3 will give me 6. And 6 times 7 will give me 42. Definitely, I have expressed what? 42 as a product of its prime factors. You can see it's very simple and very, very easy. Okay, so let's go for an example. Now see this, you see, express 15,288 as a product of prime factor. Express 15,288 as a product of prime factor. Now 15,288. I check. I start to what? My smallest prime number. My smallest prime number is what? 2. I go with 2. Can 2 go into 15,288? Yes. How many times? 7,644 times. So I have my what? I have my 2. You can see the 2 here now. This is a 2. So 2 can go into 15,288, 7,644 times. So 2 times 7,644 will give me 15,288. Now I check again. Before moving to the next one, can this 2 still go? Yes, 2 can still go into what? 7,644. So now 2 into 7,644 will give me what? 3,822. So I have what? 15,222 is equal to what? 2 times 2, because what? I've introduced this 2 again. Since 2 can go into 7,644, I've introduced it. But now this 7,644 will reduce because what? 2 is going to 7,644, 3,822 times. So for me to get this 7,644, I multiply 2 times what? 3,822. It will give me this. Then this 7,644 multiplied by 2 will give me what? 15,200, 2,288. So I check again. Can 2 still go into this 3,822? Yes. How many times? 1,911. I put down my 2. I check again. Can 2 still go into this 1,911? No. I move to the next what? Move to the next prime number, which is 3. And I check. Can 3 go into this 1,911? Yes. How many times? 637 times. So what? I accept the 3. Now I check again. Can 3 go into 637? No. What do? I move to my next prime number, which is 5. Can 5 go into 637? No. What do? I move to my next prime number, which is 7. Now, can 7 go into 637? Yes. How many times? 91 times. So what do? I put my 7. Now I come to 91 again. Can 7 go into 91? Yes, 7 will go into 91. How many times? 13 times. I put it. Now, can 7 go into 13? No, I can't put 7 because 7 cannot go into 13. So what? I move to my next prime number, 11. Can 11 go into 13? No. So what do? I move to my next prime number, 13. And can 13 go into 11? Yes. And that is why what? I pick this what? 13. So you see now that the prime factors of 15 are these 2, 3, 7, and 13. Now, expressing 15,288 as a product of its prime factor will give me what? 2 times 2, which is 4, times 2, which is 8, times 3, times 7 again, times 13, which is what? 15,200 and what? 88. So what I have successfully what expressed 15,288 as a product of its what prime factors. As a product of its prime factors. Let me take it over again. I told you that 15,288 expressing it as a what product of its prime factors. We start with what the lowest, which is 2. We started with 2. We got 7,644. You check again if 2 can go. Yes. And we have 3,822. We check again if 2 can go. Yes. And we have 1,911. We check again if 2 can go. No, 2 cannot go. So what? We go move to the next prime number, which is 3. And 3 can go. And we have what? 637. We check again if 3 can go. No, 3 cannot go. So introduce 7. And 7 can go. And to give us 91. We check again if 7 can go. Yes, 7 can go. And it give us what? 13. We check again if 7 can go into 13. No. What's the next? 11. No. The next again, which is 13. Yes. And so we have what? 2 times 2 times 2 times 3 times 7 times 7 times 13. So this is the what? The prime factor of 15,288. So we successfully what? Express 15,288 as a product of its prime factors. Now that will give bring us an end of prime factors. So you have an assignment, and the assignment says use the above method to express the following as a product of its prime factor. So you have to use the what? Use the method above to express the following as product of their prime factors. Express the following as what? Product of their prime factors. So you have what? You have 12, you have 72, 28, and 108. So you express this as the product of their what? Of their prime factors. Now let's briefly do a recap before we end this lesson. Let's do a recap before we end the lesson. So I said what? We talk about factors, and I say factors is what of a number are the number that can divide into this number without a remainder. That they can divide into this number without a remainder. And I give an example. I say 40. That 8 can go into 40 5 times, meaning that what? 8 is a factor of what? 40. And I say 5 can go into 40 8 times, meaning 5 is a factor of what? 40. And I give an example that I should express what 40 as a product of 2 factors in 8 ways, in which we did, 1 times 40 will give you 40, 2 times 40 will give you 40, 4 times 4, 10 will give you 40, 5 times 8 will give you 40, 8 times 5 will give you 40, 10 times 4 will give you 40, 20 times 2 will give you 40, and 40 times 1 will give you 40. So successfully express it in 8 ways. And then talk about prime numbers. We say what? Prime numbers are numbers that has only 2 factors, themselves and what? 1. So they are only divisible by 1 and themselves. And we say what? 1 is not a prime factor because a prime number because it has only 1 factor, which is itself. So it's not a prime number. And we give you the prime number. I say 2, 3, 5, 7, 11, 13, and so on. Then talk about prime factors. We say prime factors of a number are the factors of that number that are prime numbers. I say they are factors of that number that are prime numbers. And I give you, for instance, if you have 24, the factors of 24. You have 1, you have 2, you have 3, you have 4, 6, 8. You have 12 and 24. And I say out of these, 2 and 3 are the what? Are the prime factors, because it's only 2 and 3 out of these factors that are prime numbers. And we say to express a number as a product of its prime factors, we have to start with the what? With the lowest prime number, which is 2. You start first and check if the number is divisible, like how we did for 15,288. We check if it is divisible and divisible by what? By 2. And yes, but if it is not divisible by 2, what do? You just skip it and move to the next prime number, which is 3. But if you find out that it's divisible by 2, what do? You divide. And as we divided, we have what? 7,644. You check again if this is divisible by 2. If it's divisible by 2, you continue. You check again if your answer is divisible by 2. Then you check again if this answer is divisible by 2. If it's not divisible by 2, you move to the what? Next prime number, which is 3. And so on. And so we did it. So that is how to express your numbers as a product of their what? Prime factors. And I gave you an assignment that you use any of the following method. That you use the method I gave you. I should use the method I gave you to what? To express the following as a product of the prime factors. So I said 12, 72, 28, and 108. So with this, we've come to the end of today's lesson. Thank you very much. I still remain Samuel Babatunde. Please ensure you follow this mathematics class to have your basic understanding about mathematical concepts and solving and solutions pertaining what mathematical problems. Thank you very much. Please, if you're watching this video on YouTube, do not forget to subscribe to our YouTube channel to get more of these videos. Thank you and goodbye.